Hey everybody, thank you so much for having me. This again is controlling data overhead with the OpenTelemetry Collector. And I want to say right at the outset, this talk would not exist without this fantastic talk from Observability Day at KubeCon last year. OTTLMEY, Transforming Telemetry in the OpenTelemetry Collector Just Got Better by Tyler Helmuth of Honeycomb and Evan Bradley of Dynatrace. Fantastic pair of folks. Really, really good talk. Worth checking out. That is specific to doing one of the techniques that we'll talk about here, so that's a little more zoomed in than this talk is, so maybe useful. Okay, but why am I here talking to you? My name again is Nočnica. I've been working in observability for about 12 years. When I started in observability, nothing was called RPM or Rails Performance Management anymore, but you would still, when you clicked into a dashboard, you would find that the domain for the dashboard, like at New Relic, was rpm.newrelic.com. Because at the time, APM was intimately associated with the Rails framework for web development. So a long time I've been doing various observability stuff. You can find me about everywhere at Serverless Mom, and I work currently for Checkly, which does synthetics monitoring of services. So if we have time at the end, we'll talk about Checkly for 30 seconds, but we probably won't, so let's get into it. Okay, so let's talk about OpenTelemetry in general. These slides were not in here until I went to the speakers dinner and realized how little of today was about OpenTelemetry. So I guess who here is using OpenTelemetry at work right now? Awesome. Oh, actually, you know what? I'm gonna zip a little bit through the slide. That's 50%. I'm happy about that. So, yeah, very generally, OpenTelemetry is standards for collecting, sending, and transmitting data. And it doesn't cover, right? It doesn't cover any of this stuff over here. It doesn't show up on the screen, so I won't use that laser anymore. It doesn't cover any of this stuff on the right in green, right? Essentially, right, you could say that OpenTelemetry is a project to standardize the way the data is collected and sent without annoying anybody who currently sells APM, right? Because it integrates with current APM tools. It doesn't make judgments about how you're going to store that data, how you're going to display it. All that dashboarding, storage, and collation, right, is left as a problem for the student. So what is and isn't OpenTelemetry? I don't think we need to read this slide because we have pretty good OpenTelemetry understanding here, and that's not super critical to the rest of the talk. So I think we'll be good without covering what exactly is inside and outside of OpenTelemetry. I guess the one thing that matters, right, is that let's talk about first principles for a minute. So I broke my rule not reading this slide, but I will follow the rule here and actually read the slide. So OpenTelemetry instrumentation, like any code level instrumentation, lets you send a lot of data rather easily. Some of that data is noisy, some of it is sensitive, some of it is good but needs some tweaking. The most basic example I can think of is various services all report a username. Some of them capitalize it, some of them camel case it, some of them snake case it. And you don't want to be, well, let's get to that last one. When faced with a data collection problem for observability, it would be ideal if we could solve it without having to commit any code changes. Simple idea, isn't it? But pretty key, right? If you comment on a whole bunch of PRs to the production application that pays everybody's paycheck, right? That makes the money that pays everybody's paycheck, and say, oh yeah, when you go look at the observability dashboard, these traces don't match, so that's why I'm changing this code. That's why I'm changing it again. That's why I'm changing it again. It's not gonna go great, right? You don't wanna kick off a whole CI/CD cycle every time you're like, traces aren't matching up again, right? Oh, we're getting too many alerts about this, so I made a commit to the core application code. Not rad. And when I talk about that, like on Reddit, people are like, no, you should be able to do that. It's like, well, okay, but I live in the real world where people do get annoyed about that. So I promise we do not have to parse this entire piece of application code. This is a very basic dice roller application, which Hope might recognize as being similar demo code to what Hope is using. But it's adding 3 parameters to this transaction, and it's saying, hey, what's the user ID, and then what's the user's database key, and then it's reporting all of those to an OpenTelemetry trace. Not great. Right? Maybe we wanted the database key for some other stuff. Maybe it was useful internally to the application, but it is not rad that it is going to go to a dashboard. Maybe we've got a cool dashboard set up in the lobby of the sales center that shows us how fast we're handling all the requests, and to show how cool and sophisticated we are, it even clicks in automatically to some of the traces. So now when people walk by in Times Square, they can see a bunch of users' database keys printed on the dashboard in the window of our office. Uncool, but While this instrumentation happened inside the application code, it'd be really nice if we could fix this without having to commit to the application code. Because, yeah, we don't need to belabor the point, but that's a general idea. So where would we like to fix it without having to fix it at the top left inside that application code instrumentation? We have this nice piece right at the center, right? We have the collector that, it exists as a proxy, is a very general term for what we're talking about here, but the collector is a really good central point to do that. You can absolutely have the collector running in a place where we have not, if it gets to the collector and gets dropped at the collector level, we have not violated any of our rules for security, data sovereignty, a million other reasons. So that would be a great place to drop it. And the good news is the collector it contains a great deal of depth of complexity. So the collector exists in general in three pieces or three types of components. We have our receivers, we have our processors, and we have our exporters. And actually, filtering can be done at the receiver and the exporter level. So for example, right, oh yeah, this imports data from here, but literal time codes are also encoded from that source. So maybe there'll be a config setting on the importer that says, or the receiver that says, yeah, drop those kinds of logs, drop the debug level logs that this thing emits by default. So that is one way to do it, but generally we want to say, hey, we want to do this at the processor level right in the middle, which is essentially, it does something, right? It changes the data before we send it on. And then, yeah, you could, for the exporter level, right, that could make sense, especially if maybe you're doing something like a separate pipeline where you want to say, hey, go ahead and send this data to a separate source. Maybe that's going to be the cool public dashboard, and let's go ahead and anonymize it a bunch. And we'll talk a little bit about pipelining in a minute, because you can absolutely send data to two separate places. Maybe you have a more sanitized version that you're sending to some places. So the collector has a lot of advantages here. So just some very general stuff about the collector, right? The collector is lightweight. It can be deployed in a virtualized, it can be deployed in a containerized environment. It can even be deployed in a function as a service environment, which is wild to me to see that happen, but that is a totally real thing that people do. Is the stand up the collector inside like a AWS Lambda or an Azure function, which I'm like, excuse me? But it does work. And it might make sense, right? You're standing up something just for a few hours every night. And while the collector is supposed to be lightweight, you just don't want it running all the time. You don't want to run its container all the time. So the collector is designed for high throughput and low latency. So just to say it, many naive filters, I don't mean naive critically, but I mean, you just start writing down, oh, it'd be nice to filter this. You realize that uses state. But in pursuit of this high-level design goal, the collector by default is stateless and has very low CPU and disk space requirements, and you can even go and do a custom build quite easily that strips out stuff that even reduces that further. So you can totally deploy it in a very, very small container, which allows for models like this one, where instead of just having a collector, you have a service, it talks to the collector talks to your data store. You can have multiple collectors. Now this is probably the most extreme version, where you have, not only do you have multiple collectors, but you have multiple collectors that talk to one master collector, main collector. Now, this model, right, is probably the most advanced version you'd be doing in most setups, but what does it imply about filtering, right? What if your edge services are things that are producing tons of noise? Or vice versa, you really care about latency below 0.02 milliseconds for your edge services. You obviously don't care about that for a lot of your backend stuff or your delayed jobs or whatever else. So when you have this implemented, which there's a few reasons you might implement it this way if you've already done this, then being able to go and filter at this level to say, hey, I want to filter stuff particularly from collector A and not from collector B, very, very powerful. So I got asked, we were talking in a previous talk about when is the time to deploy multiple collectors. One of the reasons to think about is if you don't have a different config file for each collector, if it's this identical config, you probably don't need multiple collectors. You probably just have them report to one place. But once you have a separate config, it's worth thinking about. Okay, let's talk about filtering in theory. So very briefly, let's talk about cardinality. So when I first was learning about this stuff, I saw a couple of talks in a row. Some were from Honeycomb and some weren't. And I was like, wait, is data cardinality good or bad? I'm not 100% sure. This is analytics data, the performance of various pages. And if you look at it, it's oh, support /known issues. support/fac. Here's how they're all performing. Maybe it's possible that the whole support side is run by one application, but maybe not. Maybe this is useful to see this separate performance. Looks pretty useful. This, less so. So, hey, known issues, same page that was at the top of our last list, but now it's just that page over and over and over again with different user IDs in the parameter. Something I think is interesting about filtering is that this is provably worse than this nice version that shows the pass. But organizationally, it's a little tough to convince people to get rid of this user ID data. It's a little tough to say, please start dumping this. Because when you say, well, right now we're recording how well the known issues page performs for every user to a decision maker, they might say, awesome. I want to know how each user is experiencing it. The fact that your database doesn't work anymore because it has 10 million rows is not registering at that level. So when we talk about data cardinality is that each value for a metric can have many possible values. So one way of looking at it is that the path metric here has way higher data cardinality, which is fantastic. But that's not really usually what we're thinking of when we're thinking of high cardinality data. What we want is something like this, where we have that path and we have a new column for user ID. So this is a transformation that we'd really like to do in theory with our filtering, is not just saying, clamp this kind of data, dump this data set, dump it based on a regex, but saying, hey, there's this value, it doesn't belong in the path value, but it does belong somewhere in this metric information. So this is the transformation to high cardinality data that we'd like to do, sort of at a very general theoretical level for filtering. So let's talk about separation of concerns. This is not that easy to actually implement in the real world, so I don't want to pretend like I have always done a great job of this or that people do a great job of this. It's worth considering that when you go to configure the collector to filter data, all of these are things you might be trying to do. And I guess I'm just saying, leave a comment about why you did what you did, because, hey, I'm doing this to get rid of some PII that appears in the, probably readable, hopefully readable from variable names and stuff, but doing it for data normalization versus doing it because you're getting unnecessary alerts on the back end is a huge distinction. And so because you're generally going to be using a single config file in that collector, it's worth doing some labeling. It's worth doing some PR comments to say, hey, this is why we did this one. And obviously, if you're worried about data security, sovereignty, or PII, you don't want someone to be like, well, I think they just did that to avoid unnecessary alerts, but now that we've got better filtering, let's go ahead and turn that stuff back on. So really good idea to have some kind of separation of concerns if possible. Do I want to talk through these? Let's see, we covered PII, clamping runaway data, like just dropping some value, like, hey, stop creating new rows for this. Right, data security and sovereignty. Data normalization, so that's one of the ones I referenced first, which is saying, hey, uppercase, lowercase, underscores, no underscores. Very often makes sense to just say, hey, let's go ahead and normalize that at the collector level rather than trying to donk about with our database at the very end. Much, much more efficient to do it here. So let's talk about basic configuration transformations. So in this example, this is one of many, many code slides that I promise we don't have to parse in full. What this one is doing is it's saying, hey, anything that includes the following value, change its label. So if its label is cluster underscore name, change it to cluster dash name. Pretty straightforward, right? So these are configuration changes that you can make. They've existed for quite some time in the OpenTelemetry Collector. Other examples are like, hey, don't send any debug logs, right? These things that are specific configs made to handle specific problems with that data. It generally includes things like dropping a value, replacing all versions of a value with another one. Again, a configuration-based thing. Someone's installed a switch because they know this is a problem. And just as a review, we're going to talk about traces and spans in just a minute. So when we, OpenTelemetry starts as open tracing, and when we say traces and spans, we're thinking about this, right? We're thinking about, here's the whole interaction. These spans are the individual time spans with their own labels. And what matters a little bit is that they have parent-child relationships, those spans do, which is going to come up in a minute. So you can also do filtering by attribute. So this is just a filter processor, which is just saying, drop this stuff. So it's just saying, hey, if this user attribute matches these three users, go ahead and drop this span. But you can see that this is all pretty rote, right? Someone has to have run into this problem before, and we all know that we have problems with our data that no one has seen before, right? So enter OTTL. So OTTL, or OpenTelemetry Transform Language, is a domain-specific language specifically for doing this. So in general, just to say it again, when manipulating data, we don't want to be limited by config values. Data can get messed up in an infinitude of ways. Better to have a function best way to unmess it, right? Because we just don't know how we're going to need to transform our data. So OTTL enables much more complex transformations. I was watching my tape of a related talk from Open Source Summit North America. When I got on stage for that talk, I put on my reading glasses, and they didn't work. And I could not figure out why until I saw the tape way later. The lovely accessible podium was down here. And I was standing here, and I was like, why don't my reading glasses work? Because the thing was a yard from me. It was so far. Anyway, just watching that video this morning made me think of it. So OTTL enables much more complex transformations. So this is a whole bunch of transformations happening in a row. We have, most importantly, I think, a real pattern-based transformation of data. So saying, hey, like for example, right, uppercase this, snake case that, go ahead and transform this with this pattern so that you're updating every value to the correct version of that value. It also lets you find data from one place and put it someplace else. So it lets you set a span attribute. So the example where we had, question mark user ID equals at the end of a path, we could lift that value and place it as a new attribute of that span. So OTTL really lets you do very complex transformations. At the end of this talk, I will cover the many, many things that it doesn't do, but it really does enable much more free filtering and transformation of your data. So where can you use OTTL? So this is right from Tyler and Evan's presentation. So maybe updated in the next few weeks with a few more, but right now, the big one is the filter processor and the transform processor. Those are the big, cool new tools to use this language. Also the tail sampling processor. Much more is to be said about tail sampling and why it may not be a good idea, but very cool. And also in the count and the routing connector, also allow you to use OTTL. So hopefully it'll expand out. I believe it's listed as beta now. It does work, so it is worth doing. All right, let's talk about filtering in practice with some specific tips and tricks for actually running filtering yourself. So one thing is these processors are defined, processors, receivers, and exporters are defined in order here. And you can also define multiple pipelines if you want. So you can do much more aggressive filtering and export to one place, do less aggressive filtering and export to someplace else. So you can have multiple entries here for where you want to pipe traces and where you want to pipe metrics. They're also implemented in order. So for example, if you have a PII scrubber, you may want to do that first, or you may want to do it last, depending on how you're altering the data. So do think about orphaned telemetry. So if you start modifying the span ID or trace ID, the result is going to be data that no longer belongs where it should. And so you are going to get more dropped data. So it can make sense to do that. I would say in general, don't. We'll talk about why, but don't do that. But do think about the fact that orphaned telemetry is absolutely possible. Let's talk about some filters we might like to do. Apologize for the small text here. So here's some common things we might like to do. We say, hey, we have a programming language now for filters. So let me just give 3 examples of some fun filters that we might like to do. We want to drop the trace names that have been set most frequently in the last 24 hours. Hey, we've had enough traces like this. Go ahead and drop them from the last day. We want to connect orphan spans based on some other data. Hey, we see that they have the same user ID and the same transaction ID. Let's give them the same trace ID. Let's report a daily average response time for like 100% of transactions, right? We have a filter, it can do math on these values. So let's go ahead and do these. So which of these can you do with the OpenTelemetry Collector? They are, all of them, forbidden because they're all stateful, right? They're all about keeping state going for a very long time. And so the collector just has a cache as it's waiting its 5 minutes, thank you, as it's waiting its 5 minutes to go ahead and report up data or whatever you set for that batching time. And even in that time, it just has a cache you can write to. It doesn't have a full state that you can write to. And so obviously you can implement your own plugins and destroy the collector if you want to, your version. But these are all stateful things. And when you start writing a bunch of filters you'd like to do, you will think of things that require state. So remember that by default we are stateless, so we want to just operate on the data that we have right now. So going and finding a trace that we saw 15 minutes ago and connecting it is not in the cards. So that takes us to what can't you do with collector processors? A whole lot. You can't connect spans with a processor. So you can't take 5 spans that you know should be all part of one trace and say, cool, just make a trace now. You did not kick off a trace, they were not connected to begin with, that's not gonna work. If you have spans that happened inside of a trace, and you're like, cool, but you are the parent of the other, right? You actually were kicked off by this other thing. You can't create that relationship at the processor level or at the collector level. The reason is that, again, the collector needs to be very high performance. So going through and mucking with the trace relationships is going to end up extremely compute heavy. So this is not like an oopsie daisy, we didn't implement this feature. This does not currently exist because the implications are too high of a compute level. I don't have a CS degree, so I can't really tell you beyond that why that's not a good idea. I can sort of say in great generalities, but yeah. You can't drop a whole trace. So you can send an empty trace, and you can rewrite the trace ID to be something gobbledygook, but you can't drop a whole trace with the filter processor. For that, you want the tail sampling processor. And that's actually a fairly good use of the tail sampling processor, rather than what some people try to do with it. So also be cautious with metrics transformations. So transformations let you convert data types. So this is very dangerous. So if you have like monotonically increasing metrics, e.g., we sold a pair of boots, hit the we sold boots button, right? Boots sold increases by 1, awesome. You have another metric that's a gauge. How fast are we selling boots per day, right? And then you realize you have a dashboard that says that you're getting better and better and better at selling boots because you were converting a monotonically increasing data type, which every time you sell a pair of boots, it reports 65, then 66, then 67. And you converted it into how many boots sold per hour, right? So now you're like, oh, we're getting faster and faster and faster. No, you're not. You converted data types, and just one of those things. If we all remember back to being Excel jockeys in a high school science class, you realize that you can do things with averaging, converting metrics that are not smart, and that will create illusory averages, statistical illusions within your data set. So you can do it, but maybe not by default. Okay, last thing is logging with OTel. So this is a statement inside the OpenTelemetry documentation. By the way, several of these images are ripped from the OpenTelemetry documentation. It is in the slides, which are shared, but I did not say it every time because I was in too much of a hurry. Unfortunately, existing logging solutions are currently weakly integrated with the rest of the observability signals. Logs typically have limited support in tracing and monitoring tools in the form of links that use available and often incomplete correlation information. So why is that? Well, when OpenTelemetry comes on the scene, you were already sending all your logging somewhere. So OpenTelemetry did not start by implementing standard libraries for sending logging. So if you have a different agent and a different library that's sending your logs, surprise, surprise, it's not going to be super well correlated with the trace and metric information that you are sending with that library. So there is kind of a funny statement encoded in that, though. Sort of saying, well, are you saying that the goal is that like every log would be connected to a trace and every metric would be connected to a log? And that sounds cool, but it's almost like a little bit orthogonal, right? You're like, well, how would I sold a pair of boots. How's that connected to a particular transaction trace? Maybe it is, in a very simple environment, maybe it is, but maybe it's sort of not. And every time I hear this as like, hey, this is an incomplete thing, I always think of Douglas Hofstadter's book, Gödel Escherbach, where he's like, oh, there's this sort of 4-dimensional braid traveling through space. And you're like, okay, okay. maybe you really can't connect data to that level. That may not be super possible, but it is a stated goal of an OpenTelemetry project. So I guess we'll see. Thank you very much. That's been my time. My name again is Nočnica Mellifera. You can find me everywhere at Serverless Mom. Check out checklyhq.com. Do we have questions? I got a few minutes for questions. One in the back. Mm-hmm. Mm-hmm. So the question is, if you have multiple collectors, and I said, hey, one reason to know you sort of need multiple collectors is when you need multiple config files. And maybe if you're deploying 5 collectors with exactly the same config file, like think about that idea. That's not the only reason to have multiple collectors. In my example, it's like, hey, they're connected to edge services. So it is very possible, depending on the implementation of edge services, that it taking a long time to connect with the collector and send its data is going to affect edge performance for end users. So in that case, like, yeah, you absolutely need a collector running extremely close to that edge service. And the function as a service example, right, is, hey, I want to stand up a collector the second that this function starts up because I'm that worried about adding latency by having it connect to a collector that's running elsewhere in my virtual private cloud. So yeah, that's one of many reasons to run your own collector. You only want auth details to go to certain places. That's another example. But yeah, there are plenty of other just sort of functional reasons to run your own collector. Essentially, like, where should you or should you not run a proxy? Like, oh, it's going to depend on your needs. But yeah, one example hugely is just reducing latency between the service and the collector. Other questions? That was a great one. Thank you. Okay, I have 2 quick plugs to do. Number 1 is buy one of these. This is an ARANET 4. It is a CO2 monitor. And what you want to do is you want to open a window if that goes above about 1,000. As long as it's below about 600, no one in that room is going to give you COVID-19. But if it's above about 1,200, they probably will. And what you'll do when you turn it on in your kitchen is you will find out that your kitchen has the CO2 level where if you are given a sheet of math problems, you will score about 20 to 30% worse than if you were outside. And a lot of people live that way in their apartment. And they say, God, every time I take a walk, I always get these great ideas. And I'm always able to write a quick email so much better than when I'm at home. They go home to their place with no open windows and an AC system that doesn't cycle into the outside air. They're like, what's going on with me? Okay, I had time for 2 plugs, so here's the second plug. Checkly has been adopting OpenTelemetry standards in how it transmits data, and was even able to do some really cool shit in just a week or 2, really, really impressive. In this case, sending its synthetics data. So Checkly is a synthetic user that goes and checks your site for multiple geographies with a very, very detailed library for simulating user behavior, and it's able to send that data over to CoreLogix as of a couple weeks ago using the OpenTelemetry standard, which is just fantastic. And so yeah, if you go check out Check the HQ, you'll see more about this. All right, those are my plugs. Those are my questions. Thank you so much, everybody.